Yeah, nobody's forcing you to come through that door and sit down. All right, we are going to do 7-2.
So you don't have to do like a loop-de-loop. Well, not going. I guess you're going to group. You're not going anywhere? You're going to town, you're not going to group.
Okay, we are going to be hypothesis testing with a program today for both sections. So hypothesis testing with a program.
Why are you? No, it's not actually. You in trouble for your act? No.
Okay. The steps are kind of the same all of the way through, but the information's different. I think I just want to do the summary part. So anytime you use a program, doesn't matter, we're going to be doing 3 different programs, the z-test, the t-test, and then the one-prop z-test. At the end of the program, what it's going to give you is a p-value. And if you read the directions on that last problem, it said use a p-value, but I said ignore that. Okay. So when you're hypothesis testing with a program, the program will give a p-value. And what we're going to do with this p-value, because we need to know, well, okay, if they give me a p-value, what it is it's the probability of that sample happening. We still have to decide at the end of the test, did it reject the hoe or fail to reject the hoe? And the way you tell is this. If the p-value is less than or equal to alpha. So you're comparing to that alpha. So if the probability of the sample happening is smaller than the alpha, you are going to reject the hoe. So then the other side of the coin, if the p-value is bigger than alpha, you're going to fail to reject the hoe. So all 3 programs, when they're done running, after you put in all the right information, will give you a p-value. So if we are hypothesis testing for the mean, with one of 2 things, large sample and small sample. If it's a large sample, the name of the program you're going to use and we'll just think about the by hand ones. What was the difference between the large sample and the small sample by hand? Z and T. That was the only difference. We did IMS norm to get a Z when there were big samples, and yesterday we looked at the T table to get a T. So the name of the program for hypothesis testing with large sample, z-test. And we'll look at what that takes in a minute. So it's real tricky. If you've got a small sample, what do you think the name of the program you're going to use is going to be? T-test. And these are in the same spot as our confidence intervals from the last chapter. So let's go with an example. And then you tell me whether you should be doing the z-test or t-test, and we'll go through the steps. There's still a couple of steps you got to do to write down. But so example 1. Let's go. Let me go here. Chapter 7-2. Okay. The homeowners claim that the mean speed of automobiles traveling on their street is greater than the speed limit of 35. miles per hour. You're going to sample 100 automobiles. And you find that the mean speed was 36 miles per hour. With standard deviation of 4 miles per hour. We want to test this at 5%. Okay, we're going to do this with the program eventually here. Okay, even though we're going to do it with the program, we still have to rewrite our claim, identify ho and ha, because that's what's going to help us with our chart at the end. So first step, always, always, always have to rewrite the claim. Is that the mean speed, so mean mu, is greater than 35. So what is that making the claim?
The ha.
The ha. So the ho that we're going to test is less than or equal to 35. Okay. Because we're testing for the mean, should I be doing a z-test or a t-test on this problem?
A z.
Why a z?
Because the sample is greater than 30.
Here we go. This 35 tells you to do a z. So we're going to run z-test. And let's see what goes in z-test.
Schwartz, are you sure it's not the 100 that makes it over 30?
Oh,
I
jeez.
know it's the same.
Oh, gosh. 100. 100 makes it over 30. My bad.
Yeah.
You would be correct.
Outcome, but you were
Yes,
right.
I did totally circle the wrong thing. All right, so turn my TV on. You corrected me, Kenley. I stand corrected. Or I should say I sit corrected. Okay, check out the program, see what goes into it. So we're going to stat, over to test. And the very first one is the z-test, because we're hypothesis testing, so all of our programs are going to end in test. So it's the first program. Go over to stats. We're always going to use stats. Right, Katie? We're always going to use stats. Okay. Mu0. What do you think that wants?
35.
Yeah, the mu from the hoe. That little 0 is the 0 like on the hoe. So our mu in the hoe is the 35. So we're going to put 35 there. Okay. They want a sigma. I don't really have a sigma, but what do I have that's close to sigma? The S. I have the sample standard deviation. We're allowed to, because these are approximates, put in the S, because that's the only standard deviation I know. So we're going to go with the 4 there. Sample mean, 36. Sample size, 100. Now, take a look at the next line. It says mu. You've got a not equal to, mu0, less than, mu0, greater than, mu0. Forget about the mu0 that's there. What 3 signs are across there? Which?
Not equal to,
Less than, and greater than. Those are all which hypothesis, ho or ha? They're all ha. Which ha did we write? Greater than. So you want to have the greater than one highlighted. So that's the third one over. Make sure everybody, this is the one people kind of get confused on. So ignore the mu0, pretend that's not even there. I don't even know why they bothered putting it in there. Not equal to, less than, and greater than. You want to highlight your ha sign, which is the greater than. And then go down to calculate. Well, that was quick. There's a whole screen of information there. Only one number helps us make our decision. What number did I say to look at?
The P.
The P. So all I want you to do after this is say that P equals 0.006. And this is telling me the probability of this hoe happening, because we test the hoe. At the top, I told you how to interpret this now. How does this P compare to alpha? Is it bigger than alpha or smaller than alpha?
Smaller.
If alpha is 5%, do you agree that P is smaller than alpha?
Yes.
So what should we make our decision?
Reject hoe.
Reject the hoe.
George,
Yes.
what one did you choose for the mu, or the mu? Never mind, I got it.
Okay. Thank you, because I wasn't sure what he was talking about. Okay, so now we got to finish up with our nice little tree diagram here. Our claim was the ha.
Wait, go back down, please.
Oh, claim was the ha. We rejected the ho, so what are we going to say about the claim?
True.
Claim is true.
Thank you for clarifying.
Does it get harder?
No. So the only thing that's going to be is, boy, do I pick out the right test when they're all mixed together. That's the hard part.
That's easy. That's not even hard, George.
Okay. And I do have them all mixed together on a worksheet today, so you have a little...
Give me a challenge, George. So we're just doing an example of the small sample?
Yep, and then we're going to be done. We like this part of the year, don't we?
We have a worksheet today.
Yep.
I like worksheets.
How many problems are there?
Oh, I don't know. Okay, so our last one then.
But it's, he said that it wasn't like the type of law. It's just like.
Let me go with sample 2. Back to here. Let's see, average mean of 150 sales per day. Oops, sales, that's bad, per day. You suspect that this average is not accurate, so you randomly select 25 employees, and you find that their mean sales per day was 143. With standard deviation 15 sales per day. Test this at alpha equals 0.01, and we are going to assume that the population is normal.
We have to look for that on this one too.
On small samples, yes. Big samples doesn't matter. Small samples, you have to know that it's normal or you can't do it.
All right, George, I'm ready to go.
Okay, so we rewrite the claim.
Right.
The claim is about a mean.
The mean is equal to 150.
Is equal to 150.
Ho.
Ho.
The mean is not equal to 150. Ha.
Ha.
So say we put u, or mu, alright, equals blah blah or whatever, and it's supposed to be like x bar equals.
Well, the claims are always about population. I will mark that wrong.
Huh?
You see, because all of this hypothesis testing, the claims that they're making is about a population. And then we use a sample to test that claim about the population.
That's always
So,
gonna be mu.
that's always going to be mu.
Don't matter what.
Okay, so, because it's a mu, you have the option of z-test or t-test.
T-test.
Why t?
Because it's less than 25. the sample, or less than 35.
Yeah, the sample is 25. I'll circle the right number this time, which is less than 30. So you're going to run your
Sometimes it's charm.
t-test. So let's see what's in the t-test program. See if there's anything confusing there.
There's none.
There's not?
No.
So stat, test, test. T-test is number 2. Same stuff as the last one. So the mu from the whole is 150. Sample mean is 143. Standard deviation, 15. Sample size, 25. And then which sign am I highlighting? Not equal to. Down to calculate.
So are we still looking at P?
Always, when we're running the program, we're looking at the P. You don't care about any of that other stuff that comes up with.
So why are we using T?
Why are we using T? Because it's a small sample, under 30. 25 is under 30. So all I care about on here, P equals 0.028. What do I compare the P back to?
The whole.
No,
Oh, the
alpha thing. So how does this P compare to 1%?
It's
So
greater
P
than.
is greater than alpha. So what decision do we make when it's greater?
Fail
Fail to reject the whole.
Neef. Neef.
So the claim was the whole. We're failing to reject the whole. Neef. We're not going to be able to say that person's lying.
Wait,
The neef?
the E alligator fish.
Oh, you agree that the P was 0.028.
Yes.
You agree that alpha is 1%. How does P, this 2.8%, compare to 1%? It's bigger. So I wrote P is bigger than alpha. And at the beginning of the notes, the first 2 things I wrote down, where's my paper? Right here. I said right here, if the P value is greater than alpha, you fail to reject the whole.
Oh, okay.
If this is all we're doing, this is super easy.
Okay, good. That's all we're doing.
Okay, so we're done.
So I've got a worksheet.
Sweetness.
I know. We can't have it that easy every day.